Here is 9.5. We're talking about applications of trigonometry. In particular, navigation and surveying. And today we're focused on surveying. All right, what you're really going to see here, we're going to do the exact same kind of problems we did in day one. Surveying is a little bit different than course navigation. It's a different way of reading the same information. You'll see here we have a course right there. And here we see some notation that's a little bit different. In the first day, we had said that your course is just a 3-digit number between 0 and 360. And it corresponds with that direction in a circle. Surveying uses angles with directions. It always gives an acute angle. So this number will never be more than 90. The way it's read is it first gives us our reference. And very often, like before, our reference can be north. From north, this direction opens up 20 degrees to the east. Okay, that is represented by the E right after the 20. It would be read north 20 degrees east. Okay, now one of the nice things about this method is that we're in the general direction that we're moving is to the northeast. Surveying depicts that information. We see NE, we're going northeast. The next example we'll get to, I know right off the bat, we're going northwest. This next one that we'll look at, we're going southeast. Okay? It can be a little bit tricky to get comfortable with both course and surveying. With a little practice, you'll get used to it. They both have their strengths. Okay? Course bearings that we looked at in day one is relatively simple in how it works. This is a little bit more intuitive. It attempts to kind of to be connected to common sense, essentially, by having the direction depicted. So here we go. North 50 degrees west. I go to my reference of north. I go to the west about 50 degrees, and that would be my course. Again, I'll mark that angle between north and west as 50 degrees. This next one uses the reference of south. Now I'm using this direction of due south as my reference. That didn't happen before. Okay, surveying, we can do that. 20 degrees to the east would mean go 20 degrees in that direction. Okay, that would be 20 degrees. South, 20 degrees east. Here's a few more. Okay, a combination of the two. All right, 75 degrees would look something like that. And again, here is kind of the downside of course bearings, 200 degrees. Anytime we saw that, we had to think back to, okay, what direction am I going? Due south is 180, due west is 270. That's just a little bit west of south. Okay, a little bit west of south. In fact, if I wanted to write that, I could use south as my reference point and then go 20 degrees west. Okay, those two would mean the same thing. They're referring to the same direction, 200 degrees and south 20 degrees west. North 50 degrees west would be just like this, where again, this angle is 50 degrees, okay, from due north. Here we're referring to south, and we are looking 25 degrees to the east, and again the angle in between those two, that would be 25 degrees. All right. Really what we want to do is get comfortable using both. All right. Like I said at the beginning of the lesson, we're not going to do any problems that are any different. We just want to start to throw in surveying directions. So we can use these and these. All right, we'll look at two examples here, one to set up a diagram, the other to solve a little problem. Notice this one right here doesn't use the new surveying directions. This just uses the course bearings that we did in day one. The second example, we'll look at the new stuff. All right, so we have a plane. Again, anytime we're using just the regular course bearings, we're always referring to due north, and we always open up clockwise. Okay, 120 degrees was something like that. Okay, so it's going 400 miles per hour for an hour, so this would be 400 miles. This angle right here would be 120. Once again, I reference north. Now I change and go 70 degrees. At 450, that should say miles per hour. Okay, so I go 900 miles. My proportions are a little off because that side should be quite a bit longer. This angle relative to due north is 70 degrees. And then what I'd be looking for is right here, that distance. Because this angle right here is 120, I know that this one is 60. That whole angle right there is 130. I'd be all set up with side angle side to use the law of cosines to figure out the distance from the original position right here to the final position right there. Okay, it doesn't ask me to do it, so I don't have to. You could certainly, if you wanted extra practice, you could go ahead and give this one a shot. The law of cosines will get you to where you want to go to find this side of the triangle right over here. All right, here we go. Similar problem, but again, notice we're using surveying directions. Okay, but similar type of problem. Okay, it says from a granite post proceed 195 feet east. Okay, so well, I'll start with my granite post. So that was just due east. Okay, a couple things I want to mark. That's a 90-degree angle because I traveled due east. And I also know that the length of this side is 195 feet. Okay, then, here we go. We will go along a bearings of south, 32 degrees east. So let's start right away. Here is a reference to south, and I am going to go right here. That angle is going to be 32 degrees to the east of south, and that side is 260 feet. That leads me to this location. Then we switch and go south. So again, I'm going to make a reference to south. And now we go 68 degrees west of south. So that is 68 degrees right there. And that side is 385 feet. And then I would connect that back to my original position. Okay, that side that I just drew in would be unknown. Okay? Find the area of the plot of land. All right, find the area of that plot of land. Now it's quadrilateral, so I'm hoping you are thinking right away that we need to decompose this shape. Okay, definitely need to decompose it. I would go right down the middle here. Triangle number 1, triangle number 2. We've looked at several of these decomposition problems. We're going to handle this one in the exact same manner that we have the others. Okay, I'm hoping on a test that you would think to do that you know, we didn't. The only method we've looked at for finding the area of a quadrilateral is to break it down into triangles. Okay? I got triangle 1 and triangle 2. I'm running a little short on space here. I'm not sure I'll work this one all the way through, but I do want to give you a bit more information on strategy, how to handle this problem. Okay? Now, as far as area goes, we should be thinking area of a triangle is 1/2 AB sine C. Remember, this is really about the side angle side situation. This right here is a 90-degree angle, so this whole angle inside of the triangle is 122 degrees. Right now I'm specifically thinking about triangle number 1. Okay, just like before, we are going to take these two cases and we are going to look at them totally separate. Okay, triangle number 1, triangle number 2. Okay, and again, the total area of this plot of land is going to be the sum of the two triangles. Well, another one where the first triangle is a pretty cut and dry case because it doesn't take a lot, just factoring in this 90-degree angle to get this 122-degree angle to get the side angle side case that we're looking for. We have 1/2 times 195 times 260 times the sine running out of room, should be the sine of 122. Okay? 1/2 times 95 times the sine of 122. Okay, that would totally take care of triangle number 1. Okay? Triangle number 2, okay, is not such a cut and dry case. Okay? I've got a side over here. That's really all I've got. Okay, that is really all I have. So there's a couple things I need here. This particular side, let's call it x, I need to figure that out. Not to mention, let's call this theta, that angle, to get the side angle side. I'm short a side and an angle. Okay? Now from triangle 1, okay, I'm not going to work these through. I'll leave you to do the rest here. But I will give you a couple pointers. Okay? We could use that side angle side case from triangle 1 to use the law of cosines to get x. Okay? Now let's look at theta. Okay? One thing I know about these three angles put together. Okay, I'm looking right here. Theta's in the middle. Let's give another name over here. Let's call this angle phi. It's another common name for an unknown angle. These three angles put together, all right, because this one is 32. Phi, theta, and 68 degrees have to add up to 180 minus 32, which would be 148. Okay? Those two angles have to be supplementary. Subtracting 68 from both sides, I get that phi plus theta. Keeping in mind here, theta is the one I need to have to get the side angle side situation for triangle number 2. Phi plus theta is 80. Okay? Phi plus theta is 80. The key right here, and this is a new thing. We haven't seen this before. To get angle phi, I have to go back to triangle number 1, and that I am going to get with the law of sines. Okay? So first step would be law of cosines to get x. Then the law of sines to get phi. Then that will allow us to get theta by just subtracting phi from 180. And all of that will get us to the point where we have the side angle side case that we need in triangle number 2 so that we can get its area. Okay? This is really the new thing, is we need to get phi right here. Okay? But we would, after we find x, we would be able to use side angle side in triangle 1 to get phi. Okay? This is a problem we're going to look at a lot more in class. It's a lot to it. It's a pretty darn challenging question. So see if you can take this, apply it, finish it on your own. If not, we can certainly talk more on this one.